Have you ever wondered what happens when a star, thousands of times more massive than our Sun, enters the terminal stage of its stellar evolution?
The answer lies in one of the universe's most astonishing creations, the neutron star. Imagine something no bigger than a city, yet so dense that a spoonful of its material could outweigh entire mountains on Earth.
We will explore how these spectacular objects come into being.
Massive stars burn through their fuel in the heart of cosmic furnaces, only to implode under their own immense gravity once fusion no longer provides support.
This cataclysmic collapse triggers a mind-blowing supernova, ejecting outer layers into space, and leaving behind a core made almost entirely of neutrons. Next, we will examine the staggering forces at work inside these remnants.
Gravitational fields billions of times stronger than our planet's. Magnetic fields that can twist and distort light itself. These extremes define the realm of the neutron star, and despite their tiny size, they can broadcast their presence across the galaxy. Rapidly spinning pulsars send out beams of electromagnetic radiation like cosmic lighthouses, while merging neutron stars generate gravitational waves, ripples in the very fabric of space-time.
Ready to uncover the secrets?
Behind these compact titans, let the journey begin. Stay tuned for more cosmic wonders. If you find this content enlightening, let us know in the comments, and don't forget to like and subscribe for future explorations of the universe.
Stars are born, they live, and they die. Massive stars, much larger than our Sun, die in spectacular explosions called supernovae. These explosions are some of the most powerful events in the universe. After a supernova, the core of the star is left behind. This core is incredibly dense and hot. If the core is massive enough, it will collapse under its own gravity. This collapse is unstoppable. The protons and electrons in the core are squeezed together. They combine to form neutrons. The core is now a giant ball of neutrons. This is a neutron star. Neutron stars are incredibly small and dense. They are only about 12 miles across. But they can weigh twice as much as our Sun. Imagine squeezing all the mass of the Sun into a city-sized object. That's how dense a neutron star is. This incredible density gives neutron stars some very strange properties. We'll explore these properties in the next section. Neutron stars are exotic objects. They are not like anything we experience on Earth. Their density is almost impossible to comprehend. Think of the heaviest thing you can imagine. A mountain, a skyscraper. Now imagine squeezing all of that mass into a teaspoon. That's about the density of a neutron star. This extreme density gives neutron stars incredibly strong gravity. The gravity is so strong that it warps space-time around it. Even light is bent by a neutron star's gravity. This strong gravity also affects the neutron star itself. It forces the star to be almost perfectly spherical. Any mountains on a neutron star would be just a few centimeters tall. The interior of a neutron star is still a mystery. We don't know exactly what it's made of, but we think it might be a superfluid. A superfluid is a liquid that flows without any resistance. It's a very strange state of matter. Some neutron stars have another amazing property. They spin incredibly fast. These spinning neutron stars are called pulsars. Pulsars emit beams of radiation from their magnetic poles. These beams sweep across space like a lighthouse beam. If the beam happens to sweep past Earth, we see a pulse of radiation. This is why we call them pulsars. Pulsars can spin incredibly fast. Some pulsars spin hundreds of times per second. The fastest pulsar we know of spins over 700 times per second. That's faster than a blender. These rapid spins are caused by the conservation of angular momentum. Think of a figure skater spinning. As they pull their arms in, they spin faster. The same thing happened to the neutron star when it collapsed. It spun faster as it got smaller. Some pulsars spin even faster than regular pulsars. These are called millisecond pulsars. They spin thousands of times per second. We think these pulsars are spun up by accreting matter from a companion star. Section 4. Magnetic Titans, Magnetars, and their unfathomable power. Neutron stars are already extreme objects, but some neutron stars take it to another level. These are magnetars. Magnetars are neutron stars with incredibly strong magnetic fields. These fields are trillions of times stronger than the Earth's magnetic field. They are the strongest magnetic fields in the universe. These powerful magnetic fields can cause incredible things to happen. They can cause starquakes on the surface of the magnetar. These starquakes release enormous amounts of energy. We see these releases as bursts of gamma rays. The magnetic fields of magnetars are so strong that they can distort the shape of atoms. This creates a strange environment where the normal laws of physics don't apply. We still don't fully understand magnetars. They are one of the most mysterious objects in the universe, but we are learning more about them all the time. Section 5. Cosmic dances and ripples in space-time neutron stars in binary systems. Many stars in the universe exist in binary systems. These are systems where two stars orbit around each other. Neutron stars can also exist in binary systems. When a neutron star is in a binary system with another star, it can pull material from its companion. This material forms an accretion disk around the neutron star. The material in the accretion disk gets incredibly hot and emits X-rays. We can observe these X-rays from Earth. Sometimes two neutron stars can spiral towards each other and collide. These collisions are some of the most violent events in the universe. They create ripples in space-time called gravitational waves. These gravitational waves were first detected in 2015. This detection was a major scientific breakthrough. It confirmed Einstein's theory of general relativity. It also opened up a new window into the universe. We can now study the universe using gravitational waves. Section 6. Worlds of extremes, planets orbiting neutron stars. You might think that nothing could survive around a neutron star, but you'd be wrong. Astronomers have discovered planets orbiting neutron stars. These planets are very different from the planets in our solar system. They are constantly bombarded by radiation from the neutron star. They also experience extreme gravity. Despite these harsh conditions, some scientists believe that life could exist on these planets. They argue that life could adapt to these extreme environments. However, this is just speculation at this point. We need more observations to know for sure. Neutron stars' windows to the universe's secrets. Neutron stars are some of the most extreme and fascinating objects in the universe. They are cosmic laboratories that allow us to study physics in ways we never could on Earth. By studying neutron stars, we can learn about the fundamental nature of matter, the behavior of gravity in extreme environments, the evolution of stars, and the origins of the universe. Neutron stars are still shrouded in mystery, but each new discovery brings us closer to understanding these cosmic titans and the secrets they hold. Stay tuned for more cosmic wonders. If you find this content enlightening, let us know in the comments, and don't forget to like and subscribe for future explorations of the universe. As we look to the future, the study of neutron stars promises even more groundbreaking discoveries. With advancements in technology and the launch of new space telescopes, scientists are poised to uncover more about these enigmatic objects. The next generation of researchers will delve deeper into the mysteries of neutron stars, potentially unlocking new physics and providing answers to some of the universe's most profound questions. From gravitational waves to exotic states of matter, the future holds endless possibilities. Join us on this journey as we continue to explore the cosmos and reveal the secrets of the universe.